Hi everyone, my name is Micky Malvino Kunsandiwinata from Binus University International, and in this video I will be presenting to you our research titled Distributed Task Scheduler: Enhancing Load Balancing, Fault Tolerance, and Scalability in Distributed Systems. For our presentation in the International Conference for ICT and Smart Society, which will happen on the 3rd and 4th of September 2025. Just to preface before we go into the materials today, that if you're somebody who's looking to get an in-depth view of our research, then you should go ahead and check out our research paper because in this video, it will be just me sort of giving a little summary, right? Or a little recap, just a brief little introduction of what we did on our research and, our findings and stuff like that. So yeah, without further ado, let's get into the table of content. First and foremost, we have the introduction and we have the research objectives. Then we have the related works and gaps, proposed methodology, system architecture, the workflow, experimental results, and lastly, we have conclusion as well as the acknowledgements and future work. So again, for the introduction, as we know, distributed systems are very, very powerful and they are important in many of our modern platform that we use today. Like for AWS, for example, right, for their cloud computing, and then we have, obviously they have their roots in scientific computing as well, but it doesn't come without problems. And of course, one such problem is that efficient scheduling is not easy to do. And, this is because of the varying workloads that you may have in your system or your environment, random failures that could and probably will happen, as well as, issues with scaling your system up or down. And so, keeping that in mind, we came up with three main roles of what a scheduler should have, and it being, ensuring that there's fair workload distribution between all the working nodes, and, just improving resource utilization. And lastly, is to reduce downtime that occurs in the system. So for our research objectives, we have four, and that being again equal job division. So this is just to avoid any sort of overload that occurs in the working nodes. Fault tolerance, that means wherever a working node fails, right, the task that is being worked on will get transferred directly or automatically into a different active working node. Adaptable scalability, again, just the issue of having to scale your system up or down. Task prioritization, and this is, to ensure that the task that has a high amount of priority will get executed first, which is, really, really important in real life scenarios. Next, we have related works and gaps, right? Of course, with this research, we don't claim to be the first or to innovate anything new. This is more just, our sort of like tip of the hat to those systems, like to these existing systems such as MapReduce, Spark, Kubernetes, or Google Borg. And they all come with their own unique strengths. But what we realized is that, of course, there's some gaps, and that being the integration of all the different aspects of them combined together, right? So that being load balancing, fault tolerance, scalability, and prioritization or task prioritization. And some of these systems have aspects that deal with one or two or another of, these aspects, but they don't combine all these aspects together, which and that's where our contribution comes in, right? To make a unified scheduler that focuses on all these things and addresses all these issues. So for the proposed methodology, what we have for our technology stack, firstly is Redis, and this is just our in-memory storage to, store all the tasks, all the results. We have RabbitMQ, which acts as the message broker. We have Celery, which is, like the MVP of our team, right? This is the sole worker of our team. So whatever task that you throw onto it, depending on the amount of Celery nodes, Celery worker nodes that you have, they will execute the task for you. And Flask is just a RESTful API for the task submission. Um, Going to our next point, this is the system architecture. And again, just to preface, we took some of the images from our research paper, and obviously, due to time constraints and due to the size limitations, we couldn't apply all of these images that we have on the research paper to this presentation. So if you'd like to, go more in depth, of course, you probably want to go and check out our research paper. But anyways, we have, task queue, to organize and prioritize the jobs, the worker nodes, of course, which is important to execute the task. And then we also have a monitoring system to track all the tasks that are being executed, all the failures and whatnot. Yeah, and this is, I guess, just, an extra thing here. We do use load balancing via the built-in round robin technique and other adaptive adjustments, as well as automatic failure recovery. Like I said, if a task or if a worker node fails, of course, the task is going to be distributed or redistributed to another active node, and as well as priority-based execution. So this is, I guess, the important part, the workflow. So firstly, the user would have to submit the task through the Flask API. And in our example, we use the postman as the client, right, to send all the tasks. And then task enters RabbitMQ, where it will undergo through a priority queue. So the higher amount of priority task will get executed first through the Celery worker. And point number three, right, the Celery workers will fetch and execute all the tasks. And then Redis stores all the results. And then you can see the progress through the monitoring system, through the Flower application or a manual dashboard, so to speak. And if a failure occurs, of course, the task is going to be reassigned. This is for the experimental results. Some of the screenshots. This is just the visualization for the manual dashboard that we have, and then the second image for the on and Postman. Right, when you want to send a task, you have the task ID, you have the task data, as well as setting the priority and stuff like that. And once you send it, you'd get a 200 OK response. So that means that you're in, right? The task is successfully sent to the system and is going to be executed. Yeah, some of the key findings here, the load balancing is achieved, fault tolerance is achieved, scalability, you can scale the system up and down because we also use AWS EC2 for our deployment. So that's another effective way of handling the scalability issues. Prioritization, of course, the task with high priority will get executed first. So for the conclusion, our scheduler successfully enhances number one, load balancing. We have successfully enhances fault tolerance, scalability, as well as task prioritization. And again, for the deployment, AWS EC2 is really great because it depends on the workload that you have or the needs that you need to have on your system, right? If it's a high amount of demand that you want, then you can obviously, pay for their services that meets the demand of your system. And if, the need is small, then you can always just, like scale it less, and, so on and so forth. So, it's just really great for scalability. Um, Lastly is just acknowledgements and future work. So of course, I thank firstly my amazing friend, amazing classmate Shaan Gunwani in the building of this project, as well as thanking great lecturers, Mr. Feri Setiawan, as well as Mr. Raymond Bahana for the guidance and support. And special thanks to Binus, obviously, for providing the environment for our research, And lastly, just, we appreciate you who's watching this video and all the conference organizers, and for our future directions, maybe we could integrate machine learning or AI, which is, super booming right now, to the system, and then, just expanding multi-cloud, hybrid cloud scenarios, enhancing monitoring, right? Maybe you want to tweak something in during the process of task execution and stuff like that, and just developing energy efficient scheduling policies. But yeah, that's about it for our presentation for today. Thank you for watching. If you want to ask something, feel free to comment, or maybe I'll put some of our contact information in the description below. So yeah, thank you for watching. Yeah, have a great day.